Today we're going to talk about the area of complex figures. This is something we already did our little activity in the library on, and so now we're going to take it just a little step further to kind of see how that activity we did now relates to finding the area of complex figures. So you have notes that look like this. You're just going to be filling them in. If you don't have them, you can recopy, and that would be fine onto your own paper. So to find the area of shapes that make up the figure, you want to find the area of the complex figure, like in this first example. So I need to divide these up into two different shapes. Well, this is kind of already divided up for me. My large shape is obviously going all the way around like so. This is my complex figure. But it's already been divided for me by cutting it right here. So it cuts it into a square and into a triangle, right? Okay, so now that I have that, I can easily find the area of a square, and I can easily find the area of the triangle. So we've already done the first part we need to do. So this is going to be square, and then this is going to be triangle. Okay, to find the area of a square, remember whenever I'm doing area of anything, I'm going to have a formula. I'm going to plug in my numbers, and then I'm going to solve it. So my formula for area of a square is length times width. So my area is equal to 9 times 9. So my area is equal to 81. And I have to look at what we're talking about. We have feet. And remember, we're talking about it being squared. Okay, so this is my area just for the square. But I have part of my answer done now. Now I'm going to find the area of the triangle. Remember, there's two formulas I can use. I like to use this one, half BH, but you could also use BH divided by 2. So whichever one you want to use is fine with me, as long as you're using what you like. And you get the answer right. Okay, so area equals, and I'm going to plug in my numbers. Remember, formula first. Even tells me there, formula first. Now I'm plugging in my numbers. So I have half times the base. Well, the base is the bottom. Well, I say the bottom on this case, but it may not be. Actually, this could be the base, or this side here can also be the base as well, depending on how I'm looking at that triangle. So remember that in a right triangle, I can have more than one base. But I'm going to count the 6 as the base. And then the height then, I have to think about this. What is the distance from here to here? Well, it's the exact same thing as what's over here. So my height is 9. And when I do the math, I'm going to easily do half of 6. I can do that. That's 3. And then 3 times 9 is 27. So this is 27 feet squared. Okay. But now I'm not done, because what I did is I found the area of two different figures. Remember, my question, or what I'm trying to do is here. Find the area of the complex figure. That means I need to do something with these two things. So what do you think I'm going to do? Should be that I'm going to add them up, right? So shape 1 was 81 feet squared, and shape 2 was 27 feet squared. I know my answer is still going to be feet squared. And so my total area is 108 feet squared. This now is my actual final answer for what we're doing. Okay? So all we're going to do is, like I said, add up all of these. And if I had more than 2 shapes, I would add up all the shapes. This part, if you recall, is exactly what we did when we did our activity in the library. We had our first shape. We had the area of the first shape. We had the second shape, and we already had our areas figured out, and then all we had to do was add them up at the end. So the only thing we're doing here is finding the areas and then adding them up. Remember, too, it says if your figure has more than 2 shapes to add, like I just said, you're going to add all of them to get the total area. Okay, same thing, but this is now on the back of your worksheet. Another example here. I only have 2 shapes here. I have a trapezoid. This is my trapezoid. And I have a semicircle. Semicircles are a little tricky because we got a little extra thing there. And we have no formula for a semicircle on our formula sheet. But we know how to do it, so we're okay. So since we have a half circle here, we're going to find, again, the area of one shape at a time. I'm going to start with a circle. So this is a semicircle or a half circle. To find the area of a circle, the area is equal, and actually I'm going to do, because I don't have a lot of room here, I'm going to kind of put it sideways, sorry. The area is equal to pi r squared, because that would be the whole area. For example, if I had an entire circle, and I'm trying to find the area of it, I'm going to do pi r squared. But remember, I'm only using half the circle. So since I only need to have half of a circle, that's me trying to make half a circle there. Since I'm only doing half, I need to cut it in half. So I'm going to divide it by 2. That'll cut that in half. All right, so let's plug in our numbers. So area is equal to pi, which is 3.14, times the radius. Okay, well, I have a diameter here. I need a radius. So the radius is going to equal 7, because I have to cut it in half. And it's 7 squared, which means 7 times 7. I would suggest writing it out like this when you have circles, because sometimes people mess it up when they put the 7 squared. So write it all out. We know it's going to be 7 times 7. And then, again, I know when I do that math, then after I'm done, I'm going to divide it by 2. So what I wind up with is the area is equal to, when I do all that math, I get 76.9 inches squared. Okay? Okay, so that is the area of my semicircle, because we cut it in half, and that's my area of the semicircle. All right, then I have the trapezoid. So I have to think about my formula for area of a trapezoid. Area here, this is one of the ones I have trouble remembering, but remember, a trapezoid is a little bit like a triangle that has the top cut off. If I draw a trapezoid like this, it's kind of like, again, like the top part of that is cut off, right? So I know how to find the area of a triangle. It's half base times height. So I know it's going to be half. I know it's got to do with height. But on this, remember, we have 2 bases. I have this base, which is either B1 or B2, whichever one you want to call it. And then I have this base. Since I call the bottom one B1, this is going to be B2. So what I'm doing here is it's 1/2 times the height times the base. But because I have 2 of them, I have to add them up. So there's my formula. So now I plug in my numbers. Area equals half times the height was 10. The base 1, I called 18. And, oops, I'm not multiplying it, I'm adding it. Okay, so I'm going to add B2, which is 14. All right, and then when I do that math, I get area equals half of 10 times 48. Oh, excuse me. Half of 10 times 32, because 18 and 14 are 32. And then when I do the math, I wind up with area is equal to 160 inches squared. And again, all I have are 2 areas. I have 2 separate areas, but I need to find the area of the whole figure. So I need to add these up. I've got my 76.9, and I need to add that to my 160. And when I do that, I get 236.9 inches squared. So there's my final answer for the total area of that figure. So actually, I should circle that. Okay. Now we have another one. Okay, again, getting a little more complex. Now, one thing to keep in mind is they may not actually cut this apart for me. I already have this clearly cut into 3 separate rectangles. Here's 1, here's 2, and here's 3. But let's say that they didn't give me this line right here. And let's say they didn't give me this line right here. I can still do that because I can continue the line from here to make that a rectangle. And I can continue the line from here to here to make that then a square on the end there. So think about, if they don't cut it for you, think about how you can do it to cut it up and make it what you want it to be. Okay, so on this one we have, again, 3 different rectangles. So my first one is area equals length times width. I'm going to use this first one up here, the one I labeled number 1. And this is going to be area is equal to 1 times 6. That means that my area is equal to 6 centimeters squared. Okay, that's easy enough. There's 1. My second one, again, area is equal to length times width. So area is equal to 7 times 5. And that means that area is equal to 35 centimeters squared. Okay, so there's my answer for shape 2. All right, shape 3. Okay, shape 3, I'm going to extend it just a little bit here. Oops, it's a little too much. Okay, shape 3, we have, again, area equals length times width. This time my area is equal to 2 times 2. And so area is equal to 4 centimeters squared. So now I have all 3 of the areas of all 3 of the different rectangles, and I can add them all up. So all I'm doing is I have 6 plus 35 plus 4, and when I do the math, I get 45 centimeters squared. So that is my total area for those 3 figures. So that's all it is for composite area. But think about, like I said, when you see different shapes drawn, think about how you can actually cut them to make the shape your own. For example, if I had something that looked like this, oops, see, I'm doing what I shouldn't have done. You didn't see that. Okay, if I had something that looked like that, you kind of got the hint from what I was already doing when I was drawing it. You personally could just say, okay, I know that this could be a triangle there, so I have a triangle. This is a triangle. I know that I can cut it straight across here to give me a rectangle here, and then this would be my semicircle here. And then I can, again, cut it myself to find out what we're doing. Another idea would be if I had something that looked like this. Okay, if I had something that looked like that, I can't find the area of that. But again, can I cut it up? I can. All I have to do is cut right here to make that rectangle number 1, and cut right here, and that'll make rectangle number 2 and rectangle number 3. So again, think about how you might be able to cut up a shape to get yourself to where you need to be with these composite figures. So that's all we're working on there, and make sure you are practicing and making sure that you know how to do your formulas. Study your formulas because you might have a quiz on it just asking you for formulas. So make sure you're ready for that. Have a good evening.